In this video, you will learn about how to factor a quadratic trinomial, or a polynomial in second degree with three terms. Specifically, this is the case where the leading coefficient a is not 1. This is also known as the AC method, since the first step is to multiply a and c together, which are the leading coefficient and the constant. Let me know if you have any questions in the comments below. And don't forget to subscribe so you don't miss out on future videos. Let's jump right in. How to factor a quadratic or degree 2 polynomial. I do want to stress here that the highest exponent or the degree has to be 2 because many times I've actually seen students perform the quadratic method and it might be a degree 3 or a degree 4 polynomial. So pay attention to the degree. It can only be 2, and in that case, there are two methods where we can factor quadratic polynomials. One where the leading coefficient, or a, is equal to +1, and the other one is where a is not equal to 1. Now, just a reminder, what is a? A is the coefficient of the x squared term. In other words, it's the number attached to the x squared. Could we have labeled it any other variable? Sure, but typically we like to use a. The coefficient of the x term, or the number next to the x term, is b. And the number with no x terms, with no x's attached to it, it's called a constant. We call it c. So this is standard form. You definitely have seen it before, ax squared plus bx plus c. Now, do you have to put, if a polynomial is not in standard form, would it be helpful to rearrange it so that it is in standard form? A lot of people like to do that just so they can identify what a, b, and c is, and that's not mandatory. So first we'll do where factoring is not equal to 1. And I like to do this first because you'll notice that when we do the other method where a equals 1, they're going to be similar steps, except we love the a equals 1 method because there's going to be a shortcut. So the a not equaling 1, that's going to involve factoring by grouping. So again, this is kind of like an optional step 1. I did say it might help to use standard form to identify a, b, and c. Again, if you're really good at identifying a, b, and c, you don't have to do this. So a very important step, though, this is technically step 1 here, is you're going to multiply a and c together, and you're going to create a factor tree. Which ones are you going to choose? You're going to choose the factors that add up to b. And just be careful of the signs, right? It could be positive or negative. So I do stress that. So you create a factor tree of a times c, and then you choose the factors that add up to b. Now, what do you do with those factors? You're going to take the b term and you're going to split it up into two terms. They're going to be like terms. You're going to use those chosen factors as the coefficients of those terms. So obviously we'll do an example. Why is this step important is because when you factor a quadratic polynomial, more often than not, it's going to be it's going to have three terms. And so what this step does, very importantly, is it converts it into four terms. Now, why is four terms useful? Because you need four terms to factor by grouping. Okay, so the whole purpose of this method is to get something with three terms, convert it to something with four terms without changing the problem, and then we can then factor by grouping. So let's go right into an example. So the first thing that should go into your mind is this a degree 2 polynomial? You take a look at the highest exponent and you do say, hey, this is a degree 2 polynomial, so I can in fact use this method. Now notice, what is the coefficient of this term? In other words, what is a? 3. So I always like to tell students on the side to write a equals b equals c equals. And let's say you have no idea how to complete this problem. Just by doing this step, you should be getting some points because at least your teacher is looking for, do you have some general understanding of the problem? So just the fact that you identify what a, b, and c is means that you are on the path to figuring this out. So a is 3. B is, be really, really careful. It's a -8. I always see students, or not always, but many times I see students missing out on that sign, which is super important. And C is +5. So now once you recognize what A, B, and C is, we can use the steps above. Okay, so step 1 would be to identify A, B, and C. Does not have to be in standard form to do so. So very importantly, now we're going to multiply A and C together, and we're going to create a factor tree. So A times C, right? So we're going to do 3 times 5, which is 15. So we're going to do a factor tree of 15. Now, a lot of teachers will do this. They'll do 3 times 5, and they'll do 1 times 15. But I like to stress, again, we're doing positive 15. So doesn't a negative times a negative also equal a positive? So we should also have a negative 3 times negative 5, as well as the negative 1 times negative 15. I like to stress this because more often, or we actually will be doing an example later where not doing this, you might not notice that maybe something's not factorable, or again, if you get your signs mixed up, you might get this wrong. So go ahead and pay attention to the signs, I always say, right? And as a matter of fact, if we didn't do the negatives, right, notice these are the guys that we want. Why do we want the negative 3 and the negative 5? So let me go back up here. We've completed part B, number 2. So step number 3 is we want the factors that add up to B. And again, what is the B term, the B coefficient? It's negative 8. So the reason why we've chosen these factors is because when I add them together, we end up with the B term, which is negative 8, right? This is B. So we have chosen the correct factors. Again, if you're doing this in a quiz or a test, just by doing this, you should be able to be getting some points. Okay, so what are we going to do with those factors? We're going to use them as coefficients of the B terms split up into like terms. Okay, so let's do that. So first of all, what is the B term or the middle term? It's negative 8x. So what we're going to do is we're going to split this using negative 3 and negative 5 as the coefficients. In other words, negative 3x plus negative 5x. Why do they have x's attached to it? Because negative 8x is negative 8 is a coefficient of an x term. So in other words, these are including like terms. Is it true that negative 3 plus a negative 5x is equal to negative 8x? Yes. So we are not changing the problem at all by doing this step. What people do like to do, instead of a plus minus, that's the same thing as just writing minus. Okay, so doesn't matter. Now don't forget to copy the original problem. So we did have a 3x squared here, right? So it becomes 3x squared minus 3x minus 5x, and then don't forget the plus 5, we just copy that down. Okay, so we have taken something with 3 terms, and we have converted it into something with 4 terms without actually changing the problem. This is the exact same polynomial. Again, now what this does is we have 4 terms, and we can now factor by grouping. So first we need to figure out the GCF of the first group. So we can pull out a 3x from each of those 2 terms. And again, it's like the reverse distributive property. 3x times x gives us 3x squared, and 3x times a negative 1 gives us negative 3x. Now it's time to figure out the GCF of the second group. Now, some people might wonder, do I take out a negative 5 or do I take a positive 5? So again, I always like to tell people, well, it's a good thing that we do math in pencil because we can erase. So if you take out a positive 5, for example, and you notice that it doesn't work, you can always go back and change it to a negative 5. Okay, so let's say we do take out a negative 5. When we do the reverse distributive property, negative 5 times x gives us the negative 5x. And negative 5 times a negative 1 gives us a positive 5, right? A negative times a negative is a positive. How do we know that this is correct? You should have taken out a negative 5 is because the goal is to get the expression inside the parentheses to match. Now, just a reminder, this is all one term and this is all one term. So what is the GCF of both of these terms? Well, they both have x minus 1 in common. So if I take out an x minus 1, what is left? A 3x minus 5. So we have successfully factored using the a is not equal to 1 method. And again, it does involve factoring by grouping. Let's try another example. Now this one I chose specifically for the following reason. So the directions would say to factor this polynomial. The first thing that, again, you should ask yourself is this a degree 2 polynomial? You would go and look at the highest exponent and confirm, yes, it is. So next, we can identify what A, B, and C is. So A would be 6, B would be 9, and be really careful with the signs. C would be a negative 27. Now, when it is time for our first step, which is to multiply A and C, 6 times negative 27 is a whopping negative 162. We have to do a factor tree of this, and then we have to figure out which one of those add up to our B term, which is 9. Yikes. So you can do this, but it's going to take quite a lot of guess and check. So did anyone notice what we can do here? Instead of using our A, B, and C to be 6, 9, and negative 27, we can in fact make these numbers smaller. How do we do that? So I always like to tell people, always see if you can factor out a greatest common factor first, because as I said earlier in the lesson, it always makes life easy. So we can actually pull out a 3. Every single one of these terms are divisible by 3. So if we pull out a 3 times 2x squared gives us 6x squared. 3 times a positive 3x gives us the 9x. And 3 times a negative 9 gives us the negative 27. What does this do? Now, instead of A, B, and C being 6, 9, and negative 27, we are trying to factor this guy here. So now we are dealing with smaller numbers. A is 2, B is 3, and C is negative 9. So now when we multiply A times C together, we're doing a factor tree of negative 18. That is a much smaller number than negative 162. So it does make our life so much easier. So again, make sure that you always look out for the GCF, because more often than not, it will save your life. Okay, so just don't forget at the very, very end, don't forget to put that GCF back into the product, or else you will change the expression. Okay, so now it's time to do a factor tree of negative 18. Again, pay attention to the signs. Yes, 3 times negative 6 would work, but negative 3 times positive 6 would also work. 1 times negative 18, and then negative 1 times positive 18. Last but not least, we can do 2 times negative 9, or negative 2 times positive 9. So now it's time to go through each and every one of these and see which one adds up to B. Now, a reminder, we are not looking at this B. We're not looking to add it up to 9. This is the new guy here. We are looking to see which one of those adds up to positive 3. And it looks like these are our guys, right? Because negative 3 plus 6 equals positive 3, which is our B value. So again, what do we do with negative 3 and positive 6? We're going to take the middle term, which is the plus 3x, and we're going to split it up into like terms using those factors as coefficients. Now, a reminder, I am not looking at this greatest common factor. I'm going to add that at the very end. So for right now, I'm just going to copy the quadratic polynomial inside the parentheses. Just going to pick a different color here. How about blue? Right, so the 2x squared we're not touching. So just the B term, right? So instead of plus 3x, I'm going to do minus 3x plus 6x, because negative 3 and 6 were the two chosen factors. And then don't forget to copy down the minus 9. Okay, so you might be asking yourselves, could I have written it the other way? Could I have, instead of the minus 3x, you could have written the plus 6x, right? Could you have switched orders? And the answer is absolutely 100% yes. It does not matter which way you do it. You will end up with a slightly different GCF, but at the very end, you will get the exact same answer. Okay, so I did write it this way first. Now, some people like Mike probably would like to write it the other way because they might notice that the 2 and the 6 have something in common. But nonetheless, we have now gotten it successfully into 4 terms. We can now factor by grouping. So the first group has an x in common. So the GCF is x. So x times 2x gives me 2x squared. And an x times a -3 gives me the minus 3x. In the second group, we can take out a positive 3. 3 times 2x gives me 6x, and 3 times a -3 gives me a -9. So we can clearly see this is correct. Always check that the expression inside the parentheses match. And again, just a reminder that this is all one term and this is all one term. So we have 2 terms. So the greatest common factor is 2x minus 3. They both have 2x minus 3 in common. So if I take out a 2x minus 3 from both terms, what is left is an x plus 3. Okay, so again, if you split up the middle term using the coefficients written in the other order, you would have still gotten the same answer. And I did a famous mistake, right? So this answer is actually equal to the expression that we just factored, right? So if I do the distributive property, I would end up with 2x squared plus 3x minus 9, but that is not our original expression. Remember, our original expression was the 6x squared, blah, blah, blah. So how would we do that? Remember at the very beginning, we took out a positive 3, that was the greatest common factor. So do not forget to put that back. So you could just stick it right in front. Oh, and I forgot to add the parentheses there. So this is our final answer. I hope this video helped you learn how to factor a quadratic trinomial where a is not 1. Take a look at my other video where a does equal 1. That link is in the description below. If you like this video, make sure to subscribe to my channel right now. That way you don't miss out on my future videos like this one. Just click on the subscribe button.